All right, so today, let's see, we're going to talk a little bit more about lists. So more on lists, maybe a little heading for what we're going to be doing. So let's just remember how we define a list. So let's go ahead and just take a basic one. We'll just call it C. I don't know why C, but I don't know, whatever you want. But let's just put some basic elements to it. Let's do 1, 2, 3. So easy as ABC, 1, 2, 3. This is a list with 3 elements. Again, we talked last time about things like we can iterate through it. So like for num in C, we can go ahead and print C. So we talked about, not print C, C isn't a good one. Let's go ahead and just call this one my list because C, I keep thinking character. So let's update that. So let's go ahead and just define an initial list called myList. Again, don't call it list because we're going to look at a function called list that casts certain data types to lists. So don't ever call your list list. That is a function that could be used to cast iterables to a list. More on that later today. So again, for num in myList, we can go ahead and just print num, and you can see right here, we talked about iterating through it last time. We talked about appending things to a list, so we can do like mylist.append, and we can append 4, and you can see we now have one more number in that list. What we're going to go ahead and talk about first with the list today is not so much about adding, but removing elements from a list. There's a couple things we want to be careful with. So let's talk about removing elements from the list. So the first thing that would be good just to keep in mind, we don't want to mess with my list. We'll kind of keep that there. So we'll just say, Mike, let's make a new list, and I'm going to copy it. Now, we're going to talk a little bit about something known as passing by reference here in a few minutes. So what I want to do to copy it, and we'll look at the differences, I'm going to do my list, but to copy it, I need to go ahead and use this slicing syntax, which if you think about what that means, if there's no beginning, no end, it just assumes copy the whole list. So this right here is the way to copy a list. So this copies the list. And we're going to look at what would happen if we didn't put that slice notation there at the end. So you can go ahead and we can see if we print my copy, it goes and prints the same thing as my list. All right, so let's go ahead and also do one more thing. I'm going to call this alias, or I'm going to call it let's call it my alias. And so we can see what happens. I'm going to go ahead and it's called aliasing, but I'm going to do the same thing I did, but I'm not going to use that syntax with the slicing there at the end. So this is a little bit of a subtlety. And let's go ahead and here's how we actually go ahead and remove it. So let's just, I'm going to write here creates an alias to the list. An alias is basically just something that refers to something else. So I don't know if you guys ever have created an alias of a application on your program. It basically does not copy the program. It basically is a shortcut for those for maybe more familiar computer lingo. Okay, so let's go ahead and do a couple things. Let's go ahead and my copy, what I'm going to go ahead and do is use a method known as remove. And what remove will do is remove a number. So I'm going to go ahead and remove 1. So if we go ahead and print my copy now, you can see that it is just the 1, 2 right there. So it makes sense. Careful here, it is not removing the number at index 0 or at index 1, it's removing the number 1. So it might be worthwhile to see what happens if we try to remove 5. And if we try to remove 5, we get that beautiful red text that is going to enlighten us about what's happening, and there is a value error. So you always want to make sure before you remove something that you do some sort of check to make sure it exists. Or again, we'll talk about, and if you looked at the last project, you kind of have some ideas on how to catch exceptions. We haven't quite learned it formally, but you just need to be careful with removing it. So if I remove one, you could print my copy. And now let's go ahead and from the alias, let's go ahead and remove 2. So from my alias, let's go ahead and remove 2. So print my alias. And if we see that's doing what we expect right down here. So, but here's the thing to be aware of, and this is something we'll look at the stack frames here in a moment. But go ahead and print my list. Note, so if we look at this, we didn't do anything to remove from my list. Do you agree? And maybe just to emphasize this, I'm going to go ahead and just put that. So I'm going to run this, and you can see my list lost 2. So if we go, but notice my list did not lose 1 because we made a copy here. So we only have lost the number 2 from my list because my copy actually made a copy and removed from that copy 1. But my alias, which again you can see right here, we did not use this slicing notation. My alias is just a reference to my list. So with that, let me go ahead and did I pull it up for class? I did not. So let me go ahead and just pull up a Python tutor. So go ahead and play with that for a moment while I go ahead and pull up the notes or the Python tutor, which it already is made. So desktop downloads classes. Where am I going? I am going to iCloud Drive, I'm going to files, I'm going here, and I'm going to day 15. Okay, and open preview. All right, so let me go ahead. Here we go. Open. So just to visualize what is happening, you can see I have this very similar setup here. I initialized C. I made a copy of C called my list, and I removed an element from my list, and then I created an alias to it, and I removed 1. So let's go ahead and just step through this. So notice here in line 2, the first thing we do is we just create a C variable, and it is pointing to a list object. And then you can see right here, we actually make a copy of it right there. So you can see my list is actually the copy that we just referred to, but it created a new variable called my list, and it is pointing to a copy of this one. But if you look at this next one, this next step, I removed from my list, and you can see right there, it's no effect to our initial list C. But you can see here, look at how the stack frame looks. When I created alias list, it did not actually create another whole list. It created, and again, in a lower level language such as C, this is saying it created a pointer to this list. But again, in Python, it's just referred to as a reference. So it's created a reference to that list. So you can see now I remove from alias list. If when I remove 1, it also removes it from this list that C is pointing to as well. So that's a little bit of a subtlety right there. When you assign another variable to a list, that does not explicitly copy it. It just creates a reference to it that would also affect the original one. It doesn't overwrite it or anything. So a little bit of something to be aware of there. Question, yeah.
Why, we would do this a lot of the time to reassign something in past programs.
Mm-hmm.
So it just doesn't work when you're not doing it with lists.
So it's one of those things, we're assigning one variable to another. Yeah, so the behavior is different from other ones. And the reason has to do with lists can get very big. So essentially you don't want a program using up a lot of space in the computer. So it is only going to create a copy of a list if it is explicitly told to, because we don't want a program exploding up and taking like all of the memory on the computer. So this is a design decision. We have some more explicit control in lower level languages, but this is how Python is designed. It passes it by reference. Before, we've been passing by value, which means we're actually passing the value and copying it. This one, we're just passing a pointer or a reference to it. So anyway, any other questions? Yeah. Good? Okay. So with that, let's go back to the REPL. And that is, again, called aliasing. So a couple other things I already talked about. If you just remove, if you're going to go ahead and use this remove method, make sure that you check that it exists first. So, you may want to do something like if the number 4 is in, let's say, my list, then go ahead and just remove from my list, remove 4. So make sure you do some sort of catch like that. Don't just start removing things unless if you actually know it's in there. Another way that you can remove it, remove an element, is using by index is using the del keyword. So let's go, say we want to remove at index. What we can go ahead and do is use this del keyword for delete. And we can just do my list, and let's say we could go ahead and remove the 0th index. So you can see right here. I need to go ahead and print this again. So it's now print my list. So this is how you would remove something by index, by using that del keyword. Again, be careful you probably should check. So if you try to remove something at index 5, it's going to throw an index error out. Index error said, and you can read this, a list assignment index out of range. You'll also get off by 1 errors like this by just not quite paying attention to what you're trying to grab. If it doesn't exist, it's going to throw an index error. But that is one way to go ahead and delete something. Another way to go ahead and do it would be using a pop method. Whenever I think of pop, I think of Diet Coke or something, because Northeast Ohio we call Coke pop. Anyway, so what you can go ahead and do, let's say you want to go ahead and remove and store an item in a variable using the pop method. So my list, and what we can do is pop index 0. And what we can do is store the value here. So we can say the value at index 0, and that's just a variable. And now if we print the value at index 0, and we can go ahead and print my list, not my alias, but my list, you can see down here at the end, we grabbed the element at index 0, which was 1, and notice that also removed it from the list. So a pop method is nice to know about. I think we'll talk about it a little bit later. We'll talk about stacks, and then you could either place something onto a stack, or you could pop it out, pop it off, but not quite to data structures. Any questions about removing elements from a list? All right. So there's a bunch of methods when it comes to lists, and we could type these all out, but I'm going to just kind of call a couple of them out, and you're welcome to, I would encourage you to kind of load this up later and just play with it. But let's just look at a couple of them. The sort method is a good one. So if we have some lists called my list, which is just going to be 9, 3, 11, this one thing to keep in mind is the difference between methods and, oops, where'd it go? Oh, what happened there? Okay, then we're back. So one thing to keep in mind is the difference between methods and functions. Methods are attached to certain data types or classes. So you can see right here when we do mylist.sort, this actually modifies the original list. But if you were to use the sorted function, this right here, it's not going to go ahead and return the sort, or it's not going to modify the list, it's going to return a sorted one. So you can see right here where we do print sorted of my list, this returns a sorted copy, but it actually did not change the original list. The original list would still be 9, 3, 11. So a little subtlety, methods will change your original list. Functions, in this case, the sorted one does not. There is a reverse method if you just want to go ahead and reverse the original list. So that's a good one to know about. There is an index method right here, which is just going to do similar to what it would be if you were just using the bracket notation. So that's there, but be careful, it does throw a value error. There are extrema functions. So if you need the maximum or minimum value of a list, you have the max or min, and max or min basically just take iterables, anything you can iterate through. These last few are going to be important, I think, for the next project. So let's go ahead and take a look at just what these are. So if you have a string, the next problem is called wordy, or the next project is called wordy, so you'll be dealing with text and strings a lot. So if you need to go ahead and split up an actual string, you can do that using the split method. So this isn't really a method for, this isn't a method for lists, this is a method for strings, but it returns a list. So you can see right here, if we have the text hello world, and if we call on that text the split method, it will store a list of words, and you can see if nothing is specified, the delimiter or the value it uses to split, what do you guys see? Do you see what it is? How did we split these? It is simply by using a space. So if nothing is passed into the split method for the split method of a string, it's just going to go ahead and return a list of words. Suppose you have a string of a bunch of scores, and you want to go ahead and separate, and you notice they're separated by a comma. Notice that you can pass that in as a parameter, and you can see this is what it would print in nums. It's just going to go ahead and separate it based off of the comma. And if you want to put, well, let's go ahead and if you want to cast, so we have all those casting methods like int, str for stir, float. There's also the cast method for list, and what it takes is an iterable. An iterable is just something you can iterate through. Makes sense. So if you can iterate through the word hello, you can see it is going to make a list of that. So this is if you don't have a specific delimiter, you just want every character. The range actually returns a iterable, and you could get all of the numbers in that iterable by just calling the list method. So that's a nice way if you just need a bunch of dummy data that is linear. Just go ahead and call the range function, and if you actually need to work with specific parts of it, you can go ahead and just use the list method and then slicing notation. And then careful though, 10, an int is not an iterable, it is an int, so you'll get a type error because you can't iterate through ints. Lastly, the join method is a good thing to keep in mind. So this is a little bit weird. So this is just going to use the empty string, and it's going to basically put the empty string between each of the letters. So if we have the letters that are like right up here, the same ones, you can see that if we were to join these down here below, technically letters should be lowercase because it was lowercase here. But those are a bunch of methods I would encourage you to play with. But I've rambled for a few minutes, so it would be nice to give you guys something to think about and change up and give me a moment to drink. My water, just to clarify. So I have an exercise down here just to play with a little bit. So let me zoom back out and get this out of the way. So here's a little exercise just to kind of play with some ideas, put these ideas together with things that we've done before, not necessarily related to the methods above, but just a little exercise. So let's go ahead and what we want to do is let's write a function. Let me maybe clarify this. Write a function, and let's call it my grocery list. Grocery list. And what it should do is add grocery items to a list as they are inputted. I guess I called it make grocery list down here below, so I'll change it. So it's more indicative to call it make grocery list. So add grocery items to a list as they're inputted until the user enters done. So that will basically be some sort of something to watch for. And then print the sorted list. So just a little exercise just to mix up the day a little bit. I'm going to give you 3 to 5 minutes here just to experiment with it. There is a not, you could use the not qualifier. Yeah. I think not in will work. If not, I'd have to check it. This is one thing I always experiment with. Or you can always set, because it's going to return a bool. So like let's say if we have 1 and 2, 3, this is going to return a bool, and then you can always just close that and apply the not in front. I think semantically those would be the same to say not in, but if not, you can always check the in and then negate it. I'd have to always play it with it once or twice just to be sure. Because not is the Boolean operator. So here's the basic pseudocode to this. Let me give you maybe another minute. Does anyone I'm done with this problem. Well, either, I guess. All right, let's go through it together. So this is how I would do it. Again, yours might be a little bit different. So I want to make a grocery list. So I'm going to go ahead and actually start with an empty list right here. And I'm going to just do it like so. I don't know how many items I need to add to the list. I find this funny because my wife texted me while we were right after we write this function. And she's like, hey, I'm going to go to the grocery store to pick up some Diet Coke. So the boy, there's some irony there. But I don't know if the irony is anyway. But anyway, we don't know how many items they're going to be. So I'm going to go ahead and use a while loop. So I'm going to, while the item is not equal to done, I'm going to go ahead and add the item to the list. But you can see right here, with a while loop, you need to make sure that it has that, that declared before you get into the actual loop. The for loop is going to declare a variable that you iterate through. But again, this is we need to make sure that we start with some initial value. So I'm going to just set item to be the empty string first. That's just something to do, to initialize it to before we get started. You may also have chosen to maybe initialize it to none or something like that. I just am dealing with the string, so that's why I chose that. So the item is going to immediately be updated to do input. And of course, if we were writing a perfect program, we should probably do some input validation. But I'm going to just go ahead and just say enter a grocery item or done. And I'm going to go ahead and just put that in quotes appropriately. So that's going to prompt it. And what we will go ahead and do is we're going to go ahead and append to the list. So the grocery list dot append, we're going to go ahead and add that item. And once they enter done, we're going to go ahead and get out of this loop. And we want it sorted. So I think I put the pseudocode there, kind of the prompts. So we're going to go ahead and sort it. So the grocery list, I want it to be updated to be grocery list.sorted. By the way, I am intentionally doing a few things here to see if you catch it. So grocery list.sorted. And what I'm going to go ahead and do is just for item in grocery list, I'm going to go ahead and print the item. So let's go ahead and run this and see if it works. Nothing happened. Why didn't anything happen? Anyone kind of catch that part? I have to call it, so I do need to go ahead and make my grocery list. So I'm going to call that down here below. And let's see, enter grocery item or done. So let's go ahead and say, what do you guys like to get from the grocery store? Grapes, I know that. Banana, flower pots. What else do y'all get from the grocery store? Okay. Trail mix. Okay, I'm done. Okay. What happened here? Grocery list is equal to grocery list dot sorted. So, did anyone catch what the typo was there?
Sort.
It should be sort. So again, sorted is a function, not a method. So let's try this again. So let's run this. Let's go ahead and do fruit, apple, done. Okay, what is this happening right here? Notice the error is now down here on line 21. None object is not an iterable. Did anyone see what was wrong here, or why we're getting an error? So I alluded to this earlier. This method, sort, is going to sort the object in place. It returns none. So if we were to do it this way, what we would have to do is either do the sorted method like so. So if we run this, let's run that. Maybe? Why isn't that running? That is strange. There it goes. Apple, fruit, done. Notice that was fine because so the sorted function returns an actual list The other thing you could have done is you could have just called the sort method not setting it equal to anything. So that's a little bit of a subtlety when it comes to sorting, and apple done. So anyone else notice one other little bug in my function? Kenneth?
Well, the way you have your while loop set up, I think done is in the list, right?
Yeah, so done will always be in the list. And if you kind of have that by design, there's a couple ways to deal with it. It's always going to be the last item, so you might just want to just go ahead and then after you're done, go ahead and just do the grocery list. And you can just go ahead and pop off the last element like so. Since you know it'll always be the last one, you may have chose to do a conditional, you may have chose to use the delete. There's a couple of different options on how you could have done it, there was something. So let's do apple done, and you can see right there it prints as appropriate. So that was a fun little exercise, just gave you some time to experiment with strings a little bit in the context of things we've already done. Does anyone have any other questions concerning this little exercise? All right. So, all right, last thing I wanted to mention about lists, our lists of list. So very listy. But you'll encounter this if we were to do something. I think we're going to have some time to do something with data a little bit later. Like if Excel's kind of a big deal nowadays. I don't know if you guys use that. But what we can go ahead and do is, and this probably shows up most in mathematics most commonly as a matrix. So nested lists, which you could kind of think about it as a matrix. So a matrix has rows, and it has columns. So in the first row, we could just put 1, 2, 3. In the second row, what we can do is 4, 5, 6. And then in the third row, we can just go ahead and do, 7, 8, 9. 7, 8, 9. So it is possible to do lists of lists. So if you go ahead and just print the matrix here, you can see that it will go ahead and print exactly as I typed. By the way, though, if you're ever in a position where you need to make the matrix or make a multi-dimensional list, you are allowed to go ahead and use spacing like this just to make it a little bit easier to see. So you can see, let's go ahead and get that lined up. So you do have a little bit of flexibility when it comes to the actual defining of a two-dimensional list. So you can go ahead and set it up actually like a 3x3 matrix, and you can see there's no errors with that. What if you want to go ahead and get 5 here, though? Well, think about this in terms of what if you want to get that middle number? First of all, what row is it in? Second, but of course, because lists are indexed by 0, that's actually the row at index 1. And then you can just go ahead and do another bracket, and you can see right here, if I were to run this, that's how I go ahead and get this middle element in that list of lists. So that's a nested list. We'll probably work with these a little bit more after spring break, where I hope to do some basic statistics with Python. One of the projects I think in the later part of the semester may be something like a data visualization or something like that. So any questions on that one? All right. Let's talk about tuples. Tuples are essentially, let's just say this. Tuples are essentially immutable lists. So lists, let's do, these are good, like for example, if you don't want something that doesn't change. For example, dimensions of a computer, I don't know, let's say you were looking at like 1920 by 1080, you want that good old high def. So a tuple simply uses parentheses instead of brackets. So if we have dimensions, let's say we have the dimensions 1920 by 1080, and you can access the same elements the same way. So you can do like dimensions of 0 using this index notation. You can go ahead and then print dimensions of 1. And if you print that, you can see it gives me the 2 dimensions. But if something is immutable, remember that if you try to do this and I say, I want a smaller screen, let's say you want, let's go back to the old days and it was everything was like 720p. So dimension 0 was 720. If you try to run that, you can see that it says type error, tuple does not support item assignment because it is immutable. So a little bit more to say about tuples, but I would encourage you to just kind of read through the documentation, see what methods there are, but you'll find pretty much anything you can do with lists apart from changing it, you'll find something similar with tuples. So any questions on tuples? Do you all comprehend? And with that, let's introduce basic list comprehensions. This right here is fun, but a little bit tricky. I will post some additional kind of fun exercises. I don't know if I'll assign any of them because some of them are really hard, but it might be fun little challenges. So the last thing we want to talk about today are list comprehensions. Technically comprehensions in general. List comprehensions just use brackets. There technically are tuple comprehensions. There's dictionary comprehensions, but we're going to just start with our list comprehensions. So let's go ahead and suppose we wanted, let's go ahead and say we want the first, we want a list of the perfect squares less than 100. Strictly less than 100. So we want the perfect squares less than 100. Doesn't seem unreasonable, right? Be there, be square. How would we do that so far? If you kind of think about the grocery example, how would we go ahead and do that? Well, you'd have some initial list called let's just call it my squares, and we'll just do it empty. And what I'll do is I'll populate the list by just using a for loop. So for I in range of 10, because we want 0 through 81 in our squares, basically. And then what we'll go ahead and do is to my squares, we'll go ahead and append I squared. And if we go ahead and run this, we'll go ahead and run in. We'll see that we have 0 through 81, which are, well, I guess we could have clarified and say, we could also have said like non-negative. Well, we want the list of perfect squares, we'll say non-negative. Well, never mind, negative squares can't be negative. Anyway, so that's the traditional way of doing it. But if you think about discrete mathematics or something we've already learned, we have set builder notation, which basically looks like this. You have, let's say, x squared such that, and you have like a vertical bar or a colon or something like that. And we would have x is in the interval 0 through 9. So this is notation that I hope every math major is comfortable with by the time they've gone through discrete mathematics. This set builder notation essentially is the kind of the mathematics behind what a list comprehension is. So the way the syntax works for the list comprehension is as follows, is you're going to put a bracket and you're going to put some sort of variable expression. So you're going to have some expression that involving variables first. So you'll say variable expression for var in iterable and then if condition. And this last if condition is optional. So I will go ahead and mention the if condition is optional. So that looks a little weird, but let's go ahead and just do this same example using this syntax. So my squareds is going to be a list, so I'm going to set up like that. But instead of an empty list, I'm going to use that syntax. So what I'm going to do is, okay, my variable is I want I squared. So there is my variable expression. Then I'll put the keyword for, and then I'm going to put the variable, which is I, and then it's going to be in an iterable, which is the range from the 10. Just that. Does everyone see how that syntax translates to that set builder notation that we're using? We have some variable expression. And again, we used I think above we could have used x. It does not matter. We just basically define that as we go. And now if we go ahead and let's just go ahead and just delete this so you can see it's not the same. So now we go ahead and print my squares. And we get the same thing. So that is something that is in more modern languages. You don't have that in like C or Java, but you do have that in Python. I think more modern languages are more modern versions of C# or C++ have it. But let's go ahead and let's just do this one. Let's change it up a little bit. Here's a little exercise just to see if it clicked. Generate a list of the first 4 powers of 2. So again, similar, just mixing up it a little bit. I'm not working perfect squares here. I want the first 4 powers of 2. Not exercise, but exercise. Yeah.
You want like 2 to the 0th power?
It was just to get you to experiment. It's up to you. So if you want the first 4 powers, I'll say first, sure, why not? We'll change that. First 4 positive powers. There you go. So no 0. The way you would do this is just to do, 2 to the n for n in range of, and again, I don't want 0, so I'm going to need to put some sort of starting index. And if I want 1, 2, 3, and 4, where's my index going to end for range? 5.
Or include it like with a bracket?
Would you say again?
You choose for range 1 to 4, instead of putting a parentheses next to the 4, put a bracket.
Put a range 1 to 4. I mean, I can't do anything like this to do I can't use the mathematical bracket for include because I have to call the function, and again, bracket it's not going to like it like this because the bracket means I'm about to index, and again, range is a function, not something you can index into. So yeah, you just have to kind of keep in mind that range has the count iterates through the integers with the half open close on the left. Is that what your question was? Yeah, there's no sweet syntax that we can use to go ahead and do that more succinctly, but yeah, so there's that. Let's go ahead and do one more exercise just to do to illustrate like the conditions. So let's say find all of the numbers from 1 to 100 that are divisible by 7. So this is where we're going to use the conditional part. So let's go ahead and just say div. Let's store this in div by 7. And the way you're going to do this, you're going to need to check all the numbers kind of naively there because we can't take we might be able to do something fancy with roots or something. I don't know. But you want to go ahead and grab, let's say, n for n in range of 1 to 100. But you only want the ones that are divisible by 7. So how do we check if something is divisible by 7? What operator? Mod. So we can just say if that n mod 7 is equal to 0, then it'll actually go into the list. So we can print div by 7, and we can run that, and you can see right here we have all of the multiples of 7. Yeah, you probably could have done something with like 7 to the n, but then you have to maybe adjust the range using, I don't know. Yeah, there's probably, you could think.
You could just do 7 times n.
Yeah. But then you would have to find a way to stop. You would have to hard code. What would your range stop at?
Yeah.
So that's the problem. But you might be able to do some sort of mathematical equation to mess with the range. I'd have to think through it more. But
You
play with it
or
for a
you,
second.
you could do a while loop while 7 times n is less than
I don't believe list comprehensions support while loops. So it does support, because you have to go through an interval and it has to kind of know ahead of time. All right. Do you guys want another exercise? We're about out of time, or you guys just want to call it a day? You want to get some free class time out of me? I don't know. Here's a tough one though. Here's one that's not as numbery. Find all of the words in a string that are less than 4 in length. And I will go ahead and give you the string to be S is equal the quick brown fox jumps over the lazy dog. So anyway, that'll be a fun little exercise to leave us with to wrap up the day. I'm going to stop the recording. If you have any questions, let me know.